Thank you. Good morning, everyone. Apologies if you've joined us a couple of minutes ago and weren't able to get through. We're just having a few technical issues there. First of all, let me give you a very warm welcome to Merton's virtual open day and to our live tutors who are from the mathematical and life sciences subjects. Perhaps I could just start with some introductions and then we'll give you a brief overview of what we'll be covering in this morning's session. So my name is Jane Gover. I'm Merton's Tutor Admissions and Senior Tutor, and we also have with us our tutor in physics.
Hello.
Professor Hooker, thank you. Our tutor in chemistry, Dr. Michael Laidlaw.
Hello.
One of our tutors in maths, Professor Scott.
Hi.
Our tutor in computer science, Professor Ong.
Hello.
And last but not least, one of our tutors in biology, Professor Guildford.
Hello. Hi.
Thank you. So what we'll be doing today is talking a little bit about the courses and how they are specific to studying them at Merton as opposed to maybe some of the other Oxford colleges. And then we'll go on and talk a little bit more detail about the application process, just including kind of the sort of UCAS form elements, pre-interview tests, and then focusing a little bit on the interview itself, perhaps talking about the types of questions and approaches that tutors will ask. We can take live questions, so if you have come across the Slido panel on the University Merton College Open Day website, you can pop a question into the live stream session there, and I will pick those up and field them to the tutors as we go through. So if you see me glancing off to the side, then that's what we're doing. So I'll keep an eye on those, we'll field them as necessary, but I wonder if I could perhaps start with Professor Hooker, who can tell us a little bit about physics at Merton.
Well, good morning, everyone. If I was to pick a few things out about why we think Merton's a good place to study physics, probably I'll start with the fact that we have 3 full-time tutors in the subject based in theoretical physics, experimental particle physics, and my own subject, atomic and laser physics. And this combined with a good number of say junior research fellows and professorial fellows means we have a strong team of tutors, and that means we can teach most of the course, the vast majority of the course within the college. And so you get to know us and we get to know you over the 3 or 4 years you're studying the subject. I think perhaps in addition, we try hard to ensure there's good integration between the different year groups and between undergraduates and graduate students. So we have a strong family in physics and in physics and philosophy, and we have various events throughout the year which try and make that happen, such as we have a termly lecture series which is aimed at bringing in people from outside the college to discuss either research work or work related to physics, or maybe they're former physicists who've gone on to do great things in industry. So we have a sort of very happy, thriving physics community, and I think that's why we've done historically fairly well in the subject.
Great, thank you. I wonder if we could move to chemistry now, please.
Hello, yes. I would echo in essence what Simon has said, that in chemistry we have tutors in all of the main branches of chemistry, inorganic, which is my subject, organic chemistry and physical chemistry, and they're long-standing, they're permanent. And on top of that, we have a couple of other tutors in maths for chemistry and other support tutors across the branches. So you're catered very well for in being tutored at Merton in chemistry. All of your topics are tutored in-house. And when we combine that with the fact that Merton, we take roughly 5 or 6 students per year, it's a very healthy tutor to student ratio, and because of the long-standing nature of the tutors, it does mean that you get to know the tutors very well, and the tutors get to know you, students, very well, which is a great benefit in terms of a well-rounded relationship that understands personal aspects of students, whether they be academic or social context, and anything that any problems that might come up, you have a familiar face to engage with. Of course, Merton has a great pastoral and welfare team as well to do the more specific aspects of any difficulties that students might have. Like Simon said for physics, chemistry has a sort of an annual chemistry dinner where all the chemists, graduates and undergraduates and the tutors all get together for a dinner. And that is prefaced by a lecture at the moment from somebody who's perhaps in a department who's going to talk in a slightly different way about their research rather than a topic to do with the course itself, or something a little bit off at a tangent that is interesting and inspiring. And of course, that dinner is a sort of a combination of something a bit different, as well as sort of relaxing and chatting informally together. We foster a lot of coherence and cohesion within the year groups, therefore, and it's more sort of like an extended family, really. So they're the things I would sort of both reinforce from what Simon said, but also add a few extras. Thank you.
Thank you. You'll see a lot of nodding and some familiar themes, no doubt, occurring. If we could now move over to maths, Professor Scott.
Thanks. Yeah, I know I'd say very much the same thing for mathematics. So we have quite a large and very active mathematics community in Merton, and that stretches all the way from kind of incoming first-year students all the way up to the most senior professors. We also have 3 tutors in quite different subjects, so we can kind of cover quite a range of expertise. I think, the maths course is a demanding one. It's a great course, it's a demanding one, but we give you a lot of support. I think that's the kind of an important thing to say. So you've got, seeing your tutors on a weekly basis, but also there's a lot of talking to other students, and a lot of, just picking up the themes that have already emerged, a lot of integration between different groups. So we have a scheme with graduate mentors. So graduate students will talk to you, and we have ways of fostering interaction between years. Often the years do it themselves, but we also set things up to encourage it. So it's very much, people talk about maths together and do maths together. There's a lot of interaction also with computer science. Luke will no doubt talk in a second. So we work closely together. There are joint degrees. Quite a few mathematicians will do maths and physics, so there's sort of interaction with the physicists as well. Of course, we all know each other, but the students also know each other. So it's not the students sit in separate silos. It's a feature of the college as a whole that it's sort of a big community with people interacting the whole time.
Thank you. Yeah, so we take about 90 students a year, so there's lots of scope both to kind of get to know students in the years above you, but also students in lots of different disciplines, some more cognate than others. If we could perhaps now ask the same question to Professor Ong.
Yes, so Merton has been teaching maths and computer science right from the start of these honor schools. In fact, Merton was one of the 3 colleges that pioneered the straight computer science course in the mid-90s. So computer science in Oxford is quite special. It's really quite an exciting course because we emphasize both the theory and principles. I think this is quite well known, but also the practice. Perhaps this is less well known, especially the importance of programming. So most courses, except the really mathematical ones, have a compulsory practical and programming component. So if you don't enjoy programming, then perhaps this course doesn't suit you. But if you do it in Merton, then you will be supported in understanding both the theory as well as programming. I'd like to say something about our joint course, Maths and Computer Science. We have been taking students in Maths and Computer Science for a very long time. Not many universities offer such a joint course. Cambridge doesn't, for example. So in Maths and Computer Science, you learn about the basics of computer science, of course, but also you cover the core topics of a straight maths degree course, such as algebra, analyses, topology, probability, and so on. So we really build on the close relationship, the cooperation between computer scientists and maths in the university, as well as in the college. We'll
Thank you very much.
Project, straight CS people. Okay.
No, go ahead, sorry.
Yeah, sorry. So let me just finish my point on projects. So you'll be doing, for straight CS people, you'll be doing a project in your year 3, as well as year 4. And in maths and computer science student, you do a project in year 4. These topics, many of them are research oriented. They build on the research interests of the professors in the department, but also of people working in the college, of the tutors in the college, and you will also be supported on that.
Great, thank you very much. And last but not least, biology.
Thank you, Jane. Well, biology is a very fast moving subject, and big changes have been happening in biology and its teaching in the university in the last few years. The 2 departments of plant sciences and zoology are merging next year, and we now teach a 4-year degree, which you should be aware of by now if you've looked at all the materials available online. And that brings us in line with the other major sciences. In Merton, this kind of change is also visible with myself. I'm Tim Guilford. My specialism is in animal behavior. I've now been joined recently by Professor Tom Richards, who's a specialist in microbial evolution, something that's very topical at the moment. And we're the 2 permanent full-time tutors in the college, but we've also got 2 additional biologists who were involved in the tutoring and running of the course. That's Ollie Paget, who's a specialist in quantitative methods, and just to join us now, Natasha Gillis, who's a specialist in ecology and conservation. So we cover a range of subjects. The number of students is going up from about 4 a year to about 6 a year in the coming year or 2. We've got 19, I think, next, 17 in students in college, undergraduates in college next year, 19 the year after, and a similar number of graduate students. And there's a good interaction between the undergraduates and the graduates. All the kind of support structures that are common to the other sciences are there in biology too. So one thing I think sticks out is our Tinbergen Society. This is our college biology society, named after Nico Tinbergen, who is a Nobel laureate, won the Nobel Prize for Medicine for his work in animal behavior, as it happens. And this is run by the students, that could be you, and it's aimed at fostering engagement in biology and enthusiasm for biology outside the course. So that's a series of lectures through the year, a dinner like everyone else, but field trips out to go bird watching at dawn, out in the windy autumn marshlands near Oxford or other good bird watching sites, monitoring the amazing set of grassland meadows and woodlands that the college owns near to the college itself, and other things like that. So yeah, it's an enthusiastic place and place to do biology, and like the other sciences, I'd say we have a good strong history in the subject.
Great, thank you. Before we move on and talk about the admissions process in a bit more detail, I have had a question about for physics, which is, could you say a little bit more about the Roger Bacon Society?
Sure. The Roger Bacon Society is a sort of physics society. It's student-led, as you've heard about in other subjects, and it organises mainly social events throughout the year for graduates and undergraduates, including an annual dinner, but also I think a garden party, if I remember. So it's a sort of a way of getting people together across year groups and across the undergraduate, sort of between undergraduates and graduates.
Great, thank you very much. So if we move on now and talk a little bit more detail about the application process and what tutors are looking for when they select students, we'll start with perhaps with the UCAS personal statement. Obviously, this is only one element of the UCAS information we have, so we also get your kind of qualifications, GCSE or equivalent, and predicted qualifications, plus the reference from your school or college referee. But I wonder if we can just focus for a short time on the UCAS statement itself, the personal statement. Professor Scott, would you like to lead on this one?
Oh yeah. So I'd say that and when we get to admissions, then we have lots of different sources of information. And actually, for maths, I would say the most important thing is the admissions test that you will take. So you look at that, and then if you do reasonably well in that, you get invited for interview, and there's interview. We do, of course, look at the personal statement. It's a good place to let us know anything that you'd like us to know. So if there's sort of something important, or if you've done lots of Olympiad stuff, or there's something else that's particularly relevant, you can mention that. But I think it's also something not to be, for our purposes at least, I wouldn't be too worried about optimizing it. So mainly, if there's something you want us to know, let us know it. Of course, you'll be applying to other universities, so you have to think about what you put on for them as well. But because we have these additional forms of information, it's less important. It's just one factor.
Thank you. I think it's often a way in which tutors begin to get a sense of your own interests and enthusiasms. Other subjects here that have pre-interview tests, so physics, for example, similar thing, Simon?
Yes, I think for us, the most important information we have is probably the result of the physics aptitude test and interviews. Of course, we look at predicted A levels and GCSE scores, and we read the UCAS form in full and the references, etc. But probably the things to emphasize for us would be the tests and interviews.
Yeah, and similar for computer science, presumably.
Yes, yeah, very much the same. There are many sources of input. The UCAS statement is just one of several. Like mathematics, the most important thing is your test. Of course, if you do well enough, we invite you for an interview, and that is important. In your UCAS form, by all means, optimize it as you wish. For other universities, this is a very natural place for you to discuss, for computer science, any projects that you have done, which you are very proud of. Tell us your programming experience, tell us why you're interested in doing computer science or maths and computer science, as the case may be. Mention any extracurricular achievements, any Olympiad, any cybersecurity competition, and so on. Okay.
Thank you. So it's a little bit different for chemistry and biology, where there isn't a pre-interview test. Dr. Laidlaw, would you like to just say anything else about the chemistry statement?
The personal statement is sort of your opportunity to give us a window into your interest in chemistry and any experience you have, as well as any other hobbies and interests. But your interest in chemistry is formally one of the selection criteria for chemistry in the university. So if you put things down on your UCAS statement that you're interested in such and such a thing, then of course we may or we may not pick up on that and ask you to say a little bit more. So you have to be prepared to justify and to express yourself what you might say and what you have been doing. But as has been said, it's not the most important aspect of your application. We don't have a test, and therefore the interviews are the most important, as well as, of course, your predicted grades and your GCSE or otherwise background.
Thank you. And we do, of course, look at GCSEs and A-levels in context. So we take account of the kind of your educational background and some postcode information as well. So we can see what qualifications look like in individual circumstances. And Professor Guilford, is there anything you'd like to add for biology in the personal statement?
Yeah, thanks, Jane. I mean, I guess just briefly to say that, like the other sciences, academic potential is the key factor in our selection competition. But it's also my belief that an enthusiastic student is a student who will do well. And if you're genuinely enthusiastic about the subject, you will engage more, you'll work harder, you'll enjoy it more, and you will perform better. So you'll reach your potential better. And to the extent that the personal statement can reflect that, then I think it is a useful tool for us to understand who really wants to do biology, who's passionate about it, and who might be less so. So to that extent, I think it is worth exposing your real interests and the things that you've done, which would indicate that to us. And I would say that we do often, as in some other subjects, we do often pick on something in the personal statement at interview, should you get to that stage, from the personal statement, just to get the interview going. So if you put things in the personal statement as your interests, then we could well pick up on it in interview.
Yeah, so make sure you're just expressing what it is you're genuinely interested in, because it could well be the sort of the format of a question or a starting question. So we've touched on tests already, and I think, you know, probably a piece of advice that many tutors would give is have a look at the previous tests that are available online. Those will give you a sense of the types of approaches that are being asked within the papers themselves. I have got a specific question come in from a prospective student, which asks about how important the MAT is for computer science and philosophy, and what would be a good MAT score.
The MAT test is very important for computer science. It is also very important for computer science and philosophy. Computer science and philosophy is a joint course, so you will need to meet the requirements and satisfy the criteria for both subjects. So certainly for the computer science part of computer science and philosophy, the MAT test is very important.
Is there anything else that anyone would like to add about tests?
Maybe I'll say something about, since we're on the MAT test, something about preparation. I mean, the MAT test is intended, it's an aptitude test, so it's not so much testing what you've been taught as trying to test your potential. Having said that, I think it's a really good idea to prepare for it, and the best way to prepare for it is, well, firstly, by doing lots of maths so that you're good at maths, but secondly, by doing some past papers. And on the Maths Institute website, you can find, by this point, uncountably many past papers for the MAT test, so you can just sort of sit and do some practice, and just so you're familiar with the sort of the general types of questions that come up.
Fantastic. Same for physics. Anything else to add?
I don't think too much. It's we use it as a sort of way of just determining who's going to come for interview. So it's certainly important there, but it's also folded into the final decision process as well. So it's important in two ways.
Great, thank you. I've got a quick question for physics, which is chemistry or computer science A-level more useful?
I don't think we have a preference, especially since I have colleagues in both subjects on this call.
Very diplomatic. Thank you. Great. I wonder if
maths is a good idea.
I wonder if we could...
compulsory. Yes.
Yes, maths is very important for computer science as well.
Actually, I think all the tutors here would probably say a bit of maths is good. So I wonder if we could just move on now and think about the interviews a little bit, just particularly kind of the general approach that tutors might take. Obviously, those will be online for any of you applying for entry into 2022. We now have clarity on that. So perhaps we could start this time with biology, and Professor Guilford, if you'd like to say a little bit about the kind of general format and approach that tutors take.
Yes, thanks, Jane. Well, again, I come back to something that several of us have mentioned already. It's about trying to assess the candidate's potential, academic potential, not, and there is a sense, of course, a degree to which this is reflected in academic performance so far, but very much more we are looking for students who will do well with the considerable resources that Oxford and Merton in particular will throw at them during their time here. And in that context, what we're trying to do is to see how a candidate will think through a puzzle, a problem, a set of data, a graphical representation of information provided in complicated different ways. How good a candidate is at integrating information, making something of it, solving puzzles and drawing inferences and seeing difficulties in that. So it's very much more about how you think about scientific information and the context in which it's given. So I'm not going to give away any of the questions that we would ask, obviously, but you can, of course, practice these with teachers or other people. You can practice this kind of thing, but in the end, what matters is how good you are at engaging with an intellectual problem, rather than what you know. So it's very much not, of course, if you do, these problems are always dependent on you understanding the basic biology, and that is important, obviously. But the key thing is how you use information that we provide you to solve a problem.
Thank you. Lots of nodding heads again. I wonder if I can move to chemistry next, because we've got a question come in as well, which is about, have you got any interview tips for chemistry?
Well, I suppose my tips would be to know your subject so far, with how you studied at school, to try and think as clearly as you can with questions and problems that are posed to you. It doesn't matter whether you get things wrong, it's more about how you can adapt and pick up on clues and different ways of thinking about things, how you can apply what you know to circumstances that problems that you haven't seen before, and follow a discussion, really. Engage at sequential levels, really, as we move through the 4 topics. So you usually have 2 interviews, an inorganic and an organic interview, and a maths and a physical chemistry interview. And each of those components will have an aspect that we begin with, something that you're familiar with, and then we take it a stage or 2 further and see how you can respond to that. So it's trying to recognize that you will get things thrown at you that you haven't seen before, and to try and just take that in your stride and be comfortable and engaged, communicate, discuss, ask questions. That would be my advice. Although, of course, everyone appreciates that interviews aren't always as peaceful and processes as we'd like.
Mm-hmm. I think a tip we often hear is just to be prepared to think out loud so tutors can understand your thought processes. Also, don't be afraid to ask for help if you need it, because I think most tutors here would say that at some point all the applicants will get stuck. And one of the questions and things that's interesting is how they get unstuck and what point they get stuck. And there are some example questions that have been asked in previous years on the university's website. So if you did want to have a go at practicing, whether it's just talking to a friend or a teacher, you could use those as the basis, and again, just become familiar with the process of articulating how you're thinking about your subject. Would anybody like to add anything to the sort of points that have been made about interviews, or something, anything that's specific to their own subject? Yes, Professor Hooker.
I completely agree with everything that Tim and Michael have said. And in addition to communicating verbally, communicating by drawing on whiteboards, if we're doing it online, or pieces of paper, is extremely important. And if you do get stuck, just tell us what you're thinking, because you might be quite close to heading in the right direction, or you might be 90 degrees to where you should be, in which case we'll say, no, you need to sort of think about this. So do try and communicate, but write things down and scribble and just say what's going on.
Professor Scott.
Yeah, I mean, maybe just to say a couple of things about maths interviews. So firstly, we're very much focused on the maths. So we won't have a long conversation about what you did last summer or what you're interested in doing in the future. We use the time very much to sit and do some maths together. The other thing to say immediately is that we're trying to give you things you haven't seen before. So it really doesn't matter what you've been taught or what you know. We'll quickly shift onto some questions that are unfamiliar, because we want to see you deal with something new. We'll then help you through the questions, and so absolutely, as the others have said, it's important that you try to talk and tell us what you're thinking. I mean, we're very much aware that interviews are inevitably stressful. We make them as nice as we can and as pleasant as we can, but just like a job interview, it's inevitably stressful. Yeah, I think that's everything I want to say.
Professor Ong, is there anything you'd like to add on the computer science side?
Yes, so for computer science, we have candidates who have not done computer science at A level. That's fine. Computer science at A level is not a requirement, but maths at A level is a requirement. And if you have done further maths, so much the better. You will be out during the interview. We are very much like maths. We'll get to asking questions right from the start. We will be asking essentially maths questions. If you have done some computing, we may well ask some computing questions, but it is always relative to what you have done, just as Professor Scott has said.
Thank you. So I think hopefully you can see that at the end of the process, there's a huge amount of information that tutors can take into account in considering who to make offers to. And as I say, it is all done in a very kind of holistic and contextualized way. There has been a question come in about somebody whose health hasn't been great ahead of GCSEs, but they're doing better now, and how are they able then, it's a biology question, to let us know that things have improved. I guess my advice there would be to talk to your school or college referee and to just see if they would be willing to just pop something in the reference about your trajectory. So sometimes what we do see is students who might have a sort of slightly mixed performance at GCSE, they can sometimes really take off at A level, whether it's because they're suddenly enjoying their subjects, or whether it's because they've overcome some health or personal difficulties. So certainly you can have a chat with them and see if they're able to do that. Professor Guilford, is there anything else you'd like to add about that question?
Well, I'd say the same thing, Jane. We're interested in students' potential. And if there's a reason, you know, a genuine reason why there's a blip, so to speak, in their past performance, and we can see that, then that doesn't mean it's going to restrict their potential. And so we do try as best we can to see through these kinds of issues, the sorts of things that, you know, happen to real students during their school years. And so, yeah, so I think just we're focused on trying to get people who are going to do well rather than just people who have done well already.
Thank you very much. And we've got one final question, and then I'm conscious we've overrun a bit, so we'll wrap up. The question is just about a reference for an international candidate. I think the key thing that I would say there, and tutors may want to add to that, is that the references are most useful to us where they are focusing specifically on academic ability and potential. Again, so particularly in the subject areas that you may be applying to, or other relevant subject areas. Anything else to add on that? No? Okay, great. So apologies that we've overrun slightly, and again that we had a few technical difficulties at the beginning. Thank you very much for joining us today. There's lots and lots of information, as I'm sure you're discovering, on both the college's website and the university's website. If you have any questions after you've had a chance to look through that, then do by all means get in touch with us. You can also request an open day pack either on our own open day page on the Merton College website, or via the landing page on the university's open day website for Merton. And we hope you've enjoyed the session. Look forward to hopefully seeing some of you make applications in the future. Thank you very much.